Welcome back. We ended up with last video with Kolb's cycle of experiential learning and starting to hammer on the idea that learning is a process. It's a cyclic process. It goes around and around and around. Now, Kolb's learning cycle is a conceptual idea of learning. I'm a physiologist. I work with animals. I like concrete things. So what we want to do is we want to take a closer look at how the brain learns. So what I want you to do to start out with is I want you to take a piece of paper, and I'll show you what to do here in just a moment. If you happen to have the PDF and you've already got this, you can use this to draw on. Please do note that front of the brain and rear of the brain, that's important. But what is probably easier to do if you don't have that brain outline of the side of the brain is just simply to draw an oval. So it looks like that. So again, front of the brain, rear of the brain. This model, this idea that I'm going to present to you is a very, very simplified version of something that came out of Zull, the book Art of Changing the Brain a number of years ago. And I find it very helpful for understanding that learning process, what's going on in the brain. Again, it's grossly oversimplified, but it works. It works for me, and I hope it will work for you to make some sense out of how learning happens up here, but also then how we as teachers, by understanding that, can take advantage of that knowledge. So, again, it's going to be a cycle, so get ready. There's sensory input. Sight, sound, touch, etc., etc. In a classroom, a lot of times this is both either sight or sound. That's taken in by sensory and post-sensory cortex, which is kind of on the back part of the brain here. What that part of the brain does is it receives and compiles neural signals. It just pulls the signals in, that's all, from your eyes, from your ears, and so on. That's all it does. Receives those signals and compiles those signals. Takes that information and passes it on to the temporal integrative cortex, which is sort of in the middle of the brain here. This is the what is being sensed and where is it. This is what Zull calls the what and where part of the brain. So this is a part of the brain that starts to establish relationships, spatial, temporal, personal. So this is called a pencil. The pencil's here. Now it's over here. That's temporal and spatial. It was here. Now a few seconds later, it's over here. This is my pencil. This pencil belongs to Walt. You know who I am. So that's what this is doing. This part of the brain is simply establishing those kind of basic relationships. And also, importantly, it starts to integrate new information with existing memory. So you knew who I was. Well, now you know that this is my pencil. All right. So that's the only part of your brain that's working in terms of, in a major way, in terms of dealing with that level of information. It takes that information and passes it on to the frontal integrative cortex up here. This is the part, which gets really interesting, responsible for problem solving, calculating, creating ideas, assembling ideas into symbolic forms. We call that language. Many of you speak multiple languages. You have a lot of that going on in your frontal cortex. Making decisions, etc. That is higher level thinking kinds of things. This again is this idea of making meaning. This is your approach to solving that problem. It's your calculations, it's your ideas that you create, etc. Not necessarily someone else's. That information then, and whatever's going to come, you've got to do something with that, is passed on to the premotor and motor cortex, which results in motor output. Premotor and motor cortex are responsible for coordinating and causing actions, doing, reading, writing, speaking, physical testing, etc. The actual doing of that cyclic process. Now, the key is true for learning and true for us helping our students learn, is that motor output results in an action, results in another sensory input. So we see this cycle again. This idea, something comes in, things happen in the brain, and out of that comes a motor output that results, by the very action of that motor output, results in another sensory input. So this is fundamentally how the brain works. This is how the brain learns, and it's automatic. Again, it's been happening in us since we were born, perhaps before we were born. This has been going on. You know this. You learn and you learn and you learn, just kind of keeps going and keeps going and keeps going. Many times in what we do in our courses, on the other hand, is we put things in and we don't ask for the right things to come out. And we certainly don't then help our students bridging this gap. So let's very quickly review. So there's sensory input is received by the sensory and post-sensory cortex. Again, just receives and compiles signals, sends that information to temporal integrative cortex, which is the what and where part of the brain. Again, establishes these relationships, integrates new memory with existing memory, or new knowledge with existing memory, passes that on to the frontal integrative cortex, which is responsible for the higher level thinking things, the things that are active, the things we really want to do and have our students do. That passes that on to the premotor motor cortex, which results in some sort of motor output. And if things are done correctly, if things are done well, that starts another cycle. And so again, this idea that learning is a cyclic process.